Picture this: a world so similar to our own, yet twisted into something almost unrecognizable. Venus, shrouded in thick clouds of sulfuric acid, with surface temperatures hot enough to melt lead and atmospheric pressure that would crush you in an instant. Scientists call it Earth's evil twin, and for good reason. Beneath that hostile exterior lies a planet teeming with mysteries that defy explanation, secrets that have puzzled astronomers for decades. What if I told you that Venus, despite being our closest planetary neighbor, holds more unanswered questions than almost anywhere else in the solar system? From its bizarre super-rotation where the atmosphere whips around the planet 60 times faster than the surface, to the mysterious dark streaks in its clouds that vanish and reappear without warning, Venus is a cosmic enigma wrapped in layers of intrigue. Then there's the mind-bending paradox of its missing water. Billions of years ago, Venus might have been a twin to Earth in more than just size. Some theories suggest it could have had oceans, even the potential for life. But something went catastrophically wrong, transforming it into the hellscape we see today. What happened? The answers, if we ever find them, could rewrite our understanding of planets everywhere. And that's just the beginning. In this video, we're diving deep into 25 of Venus's most baffling mysteries. We'll uncover the truth behind its strangely youthful surface, untouched by the scars of time. We'll explore the eerie glowing streaks in its night-side atmosphere, ones that scientists still can't fully explain. And we'll confront the most unsettling question of all. Could there be something alive in those toxic clouds, defying every rule we know about biology? Strap in, because this journey isn't just about uncovering the secrets of another world. It's about confronting how little we truly understand, even in our own cosmic backyard. The first great mystery of Venus is one that hits uncomfortably close to home: the runaway greenhouse effect. Imagine a planet almost identical in size to Earth, with similar raw ingredients, yet transformed into a monstrous version of what our world could become. Venus didn't start this way. Billions of years ago, it might have had deep blue oceans just like ours, with temperatures mild enough for liquid water to flow. But something triggered a catastrophic chain reaction. Carbon dioxide, trapped in its atmosphere, began trapping heat like a suffocating blanket. Unlike Earth, where carbon cycles through rocks and oceans, Venus had no way to pull it back down. The planet's water vapor, once a potential life-giver, turned into a greenhouse gas of its own, supercharging the heat. Temperatures skyrocketed past 470 degrees Celsius, hot enough to melt zinc. The oceans, if they existed, boiled away into space, leaving behind a bone-dry wasteland. What's truly chilling is that scientists still don't fully agree on what flipped the switch. Some argue massive volcanic eruptions flooded the air with carbon, while others suspect Venus may have lost a crucial balancing act. Perhaps its slow rotation or the lack of a magnetic field left it defenseless against the sun's fury. And here's the terrifying thought: Earth is flirting with the same forces. Our planet's carbon levels are rising faster than at any point in human history. While we're not on the brink of Venus's inferno, the parallels are impossible to ignore. Understanding Venus isn't just about solving a planetary mystery, it's about reading a cautionary tale written in the scorched rocks of our closest neighbor. Could we one day trigger our own runaway greenhouse nightmare, or is Earth's system more resilient? The answer might be hiding in the toxic clouds of Venus, waiting for us to look closer. Now let's tackle one of Venus's most haunting questions: where did all the water go? If we rewind the clock billions of years, Venus might have been a mirror of Earth, glistening with vast oceans under a milder sun. Evidence comes from telltale clues locked in its atmosphere. Today, Venus's air holds barely a whisper of water, 20,000 times less than Earth. But isotopic studies reveal a smoking gun, an unusually high ratio of heavy hydrogen or deuterium to regular hydrogen. This imbalance suggests that over eons, Venus lost staggering amounts of water, and the lighter hydrogen atoms escaped faster, leaving the heavier ones behind. The numbers are staggering. Enough water to cover the planet in a global ocean several meters deep, gone without a trace. So what happened? One leading theory points to the sun's relentless solar wind. Without a strong magnetic field to shield it, Venus's atmosphere was exposed to a constant barrage of charged particles, stripping away water molecules bit by bit. As sunlight split water into hydrogen and oxygen, the lighter hydrogen drifted into space, while some oxygen may have reacted with rocks or volcanic gases. Another theory suggests even more dramatic events: cataclysmic volcanic eruptions releasing enough carbon dioxide to trigger a runaway greenhouse effect, boiling the oceans away in a geological blink. Some simulations even propose that Venus's slow rotation played a role, with its sluggish days creating atmospheric conditions that made water loss irreversible. But here's why this mystery isn't just academic. It forces us to rethink the boundaries of habitability. If Venus, sitting just inside the sun's so-called Goldilocks zone, could flip from water-rich to bone-dry, what does that mean for exoplanets we've labeled Earth-like? Astronomers have found dozens of worlds orbiting distant stars in similar sweet spots, but Venus reminds us that size and location aren't guarantees. A planet's fate might hinge on invisible factors: magnetic fields, atmospheric chemistry, or even geological luck. Unraveling Venus's missing water could be the key to spotting which distant oceans still have a chance and which are already ghosts. Venus doesn't just defy expectations, it breaks the rules of planetary physics with one of the strangest quirks in our solar system. Its atmosphere spins like a runaway engine, racing around the planet 60 times faster than the surface below. Imagine standing on Venus, if you could survive its crushing pressure and scorching heat, and watching the sky whip past you at hurricane speeds, completing a full lap every 4 Earth days while the ground beneath your feet takes 243 agonizingly slow days to turn just once. This bizarre disconnect, known as super-rotation, has no parallel on any other planet. Even Mars and Earth, with their weather systems and jet streams, can't come close to this level of atmospheric frenzy. So what's hurling Venus's air into this relentless sprint? One leading theory points to thermal tides, massive pressure waves generated by the sun's blistering heat. Unlike Earth, where sunlight is spread evenly thanks to our quick 24-hour rotation, Venus broils under sunlight for months at a time. The side facing the sun becomes unbearably hot, causing the atmosphere to expand violently upward while the night side chills enough to contract. This imbalance creates colossal ripples in the atmosphere, pushing it forward like a cosmic tailwind. Over time, these repeated shoves might have accelerated the air to dizzying speeds, turning the entire sky into a swirling drag race. But there's another piece to this puzzle: momentum transfer from the surface. Venus's mountains, especially the towering Maxwell Montes, taller than Mount Everest, act like speed bumps for the lower atmosphere. As winds collide with these obstacles, they don't just slow down, they redirect their energy upward, feeding momentum into the higher altitude jet streams. Think of it like stirring a cup of coffee. The spoon drags the liquid at the bottom, but the swirls spread faster at the top. Some scientists even suspect volcanic activity plays a role, with ancient eruptions pumping enough heat and turbulence into the air to kickstart this planetary-scale whirlwind. Yet mysteries remain. Why hasn't friction between the fast-moving air and sluggish surface slowed the atmosphere down over billions of years? And why does the super-rotation seem to pulse, sometimes speeding up or slowing down without warning? The answers could reshape how we understand not just Venus, but atmospheres on distant exoplanets. After all, if a world so close to us can harbor such a violent, unexplained phenomenon, what other atmospheric oddities might lurk in the cosmos? Venus's superrotation isn't just a scientific curiosity, it's a humbling reminder that even the most familiar places in space can still shock us. High above Venus's scorching surface, where the crushing pressure eases and temperatures drop to something almost survivable, lurks one of the planet's most persistent riddles, an unseen force painting dark streaks across its sulfuric acid clouds. These bizarre patches, visible only in ultraviolet light, appear like giant brushstrokes stretching for thousands of kilometers, morphing and fading over days or weeks. Scientists call this phenomenon the unknown ultraviolet absorber, and despite decades of observation, no one knows exactly what's stealing that light from the sky. It's as if Venus is hiding a secret ingredient in its toxic cocktail of clouds, something that shouldn't be there, or worse, something we don't understand at all. The leading suspect, sulfur. Venus's atmosphere is drowning in sulfur compounds, from sulfur dioxide to sulfuric acid droplets, and some of these molecules naturally absorb UV light. But here's the catch: none of them match the fingerprints left by this absorber. The way it darkens and brightens, the way it clusters in specific patterns, even the wavelengths it soaks up, all of it defies the behavior of known sulfur chemistry. Some researchers have proposed exotic alternatives like ferric chloride or even crystallized sulfur allotropes, but lab experiments struggle to recreate the exact spectral signature. It's like trying to solve a murder when the weapon doesn't match any known blade. Then there's the wildcard theory: life, not as we know it, of course, but extremophile microbes floating in Venus's temperate cloud layer, 50 kilometers above the inferno below. These upper clouds hover around 30 degrees Celsius, with traces of water vapor and even ambiguous chemical signatures like phosphine, a gas often linked to biological activity. Could the UV absorber be some kind of microbial sunscreen, a protective pigment evolved to shield organisms from the sun's harsh rays? On Earth, certain algae and bacteria produce similar compounds to survive brutal environments. The idea isn't as far-fetched as it sounds, but until we sample those clouds directly, it remains a tantalizing what if. What makes this mystery so frustrating and so thrilling is that the answer might rewrite textbooks. If it's a new form of sulfur chemistry, we've uncovered a planetary process unlike anything in our solar system. If it's life, the implications are universe-shaking. Either way, Venus is teasing us with clues just out of reach, hidden behind that glowing veil of acid and mystery. Every probe we've sent has raised more questions than answers, and that's the beauty of it. Somewhere in those swirling, stained clouds, the truth is waiting. We just have to dare to look closer. Venus doesn't just hide its secrets in the clouds. Some of its most puzzling mysteries are carved into the very ground beneath them. Take the planet's volcanic history, for example. On the surface, Venus looks like a geologist's fever dream. Vast plains of solidified lava, towering shield volcanoes, and strange pancake-shaped domes that suggest a world once drowning in molten rock. Some of these flows appear startlingly fresh, as if they oozed onto the surface mere centuries ago, not billions of years in the past. But here's the twist: despite all this evidence of recent eruptions, we've never caught Venus in the act. No spewing vents, no glowing lava lakes, not even a definitive tremor. It's like walking into a kitchen littered with warm dishes but no sign of the chef. So what's going on? The clues point in opposite directions. On one hand, spacecraft like Europe's Venus Express have detected spikes in sulfur dioxide, a gas often belched out by volcanoes, hinting at possible eruptions reshaping the atmosphere. Some lava flows show almost no weathering from the corrosive environment, suggesting they might be decades or centuries old, not geologic epochs. Then there's Idun Mons, a massive volcano with infrared signatures that could indicate relatively recent activity. But without live seismometers or orbiting eyes that can peer through those thick clouds in real time, we're left guessing. Earth's volcanoes announce themselves with quakes and plumes. Venus plays its cards close to its chest. This mystery isn't just academic. If Venus is volcanically active today, it would mean the planet isn't the stagnant tomb we once thought. It's a dynamic world, still churning with the same forces that might have triggered its apocalyptic greenhouse effect. That could rewrite our understanding of how rocky planets age. Mars's volcanoes died eons ago, Earth's rumble on. But Venus, it might be somewhere in between, sporadically waking from long slumbers or hiding eruptions under radar-shielding clouds. Upcoming missions like NASA Veritas could finally crack the case, mapping surface heat and topography in unprecedented detail. Until then, every fresh lava flow we spot is a silent challenge, daring us to figure out whether this world is truly dead or just biding its time. And that's the unsettling beauty of Venus's volcanic conundrum. It forces us to confront how little we know about the inner lives of planets, even those next door. Earth's eruptions shape continents and climates, but on Venus, they might hold the key to its entire tragic history. Did colossal volcanoes pump enough greenhouse gases into the air to boil its oceans? Could hidden magma chambers still be outgassing today, quietly tightening the planet's fiery grip? The answers might lie buried under those ancient lava fields, waiting for a probe to finally listen for the heartbeat beneath the silence. Venus has a form of snow, but not the kind you'd ever want to catch on your tongue. On the towering peaks of its mountains, like the massive Maxwell Montes, something downright bizarre happens. In the middle of a scorching landscape hot enough to liquefy metal, spacecraft have detected a strange, shimmering substance clinging to the high altitudes. This isn't water ice or even dry ice, it's a metallic frost, likely made of lead sulfide or bismuth sulfide, minerals that vaporize and condense in a nightmarish cycle unlike anything on Earth. Think about the absurdity of this, a planet where the lowlands bake at furnace-like temperatures, yet the mountaintops are just cold enough, relatively speaking, to let these heavy metals settle like a toxic dusting of frost. On Earth, snow forms when water vapor freezes. On Venus, it's a grotesque parody of that process. Sulfur compounds blasted into the atmosphere by volcanic activity, mix with trace metals like lead or bismuth. When these metallic vapors rise and hit the cooler upper slopes, they solidify into eerie, reflective coatings that glint in the dim sunlight filtering through the thick clouds. It's less like snowfall and more like the residue left behind in a smelter's chimney, a slow, creeping crystallization born from the planet's relentless chemistry. What's truly baffling is how this stuff even stays there. Venus's lower atmosphere is a churning hellscape with winds strong enough to scour the surface over geologic time. Yet these metallic patches persist, clinging to peaks like ghostly caps. Some scientists suggest the snow might constantly replenish itself, with fresh vapors rising from volcanic vents or even bubbling up from deeper crustal rocks. Others wonder if electrostatic forces, the same kind that make dust stick to your TV screen, help anchor these particles to the high ground. Then there's the eerie possibility that we're not seeing a static layer at all, but an active process with metals evaporating and condensing in a slow, metallic heartbeat. The implications stretch far beyond just another weird Venusian quirk. If lead or bismuth sulfides really are snowing onto those peaks, it means Venus's atmosphere conducts chemistry we've never witnessed anywhere else. It's a laboratory for extreme materials, forging compounds under pressures and temperatures that defy Earth-bound experiments. And who knows, similar processes might unfold on exoplanets with equally brutal climates, hinting at alien landscapes where metals rain from the sky or frosts gleam with poisonous lusters. Venus's snow isn't just a curiosity, it's a glimpse into the infinite creativity of planetary physics, where even the most hostile worlds find ways to surprise us. Every shimmering patch on those mountaintops whispers a challenge. Come figure me out if you dare. Thunder without rain, that's the eerie puzzle lurking in Venus's chaotic skies. For decades, scientists have argued whether the planet even has lightning, despite multiple spacecraft hinting at its presence. The Soviet Venera probes of the 1970s and 80s claimed to detect crackling radio bursts, the telltale signature of electrical storms. Later, Europe's Venus Express caught fleeting flashes in the clouds, but here's the catch: no mission has ever captured undeniable visual proof. It's as if Venus is playing a cosmic game of hide and seek, taunting us with clues just out of focus. If lightning does exist on Venus, it's nothing like Earth's dramatic bolts. Our planet's storms rely on water, ice particles colliding in towering thunderheads, building up static charges until the sky erupts. Venus, with its sulfuric acid clouds and bone-dry air, shouldn't have the right ingredients, yet some researchers argue its hellish chemistry might forge an alternative recipe. Sulfur dioxide and carbon dioxide, superheated by the planet's furnace-like surface, could generate charged particles as they rise and churn. Imagine droplets of sulfuric acid colliding like microscopic bumper cars, each crash stealing or donating electrons until the entire cloud layer buzzes with electricity. The resulting discharges might not be the jagged forks we know, but vast diffuse flickers, more like glowing sheets of static than concentrated strikes. Then there's the twist that keeps scientists guessing. Venus's lightning, if real, might leave behind invisible scars. On Earth, lightning splits nitrogen molecules, creating reactive compounds that fertilize soil. On Venus, the same process could rip apart sulfur dioxide, potentially fueling the mysterious UV-absorbing chemicals staining the clouds. It's a self-sustaining loop. Lightning begets chemistry, which begets more lightning, but without direct observation, the theory remains as hazy as Venus's own sky. The stakes are higher than just solving a planetary whodunit. Lightning shapes atmospheres. It could have jump-started chemical reactions in Venus's distant past, back when it might have harbored water. It might even crack molecules into fragments that, against all odds, assemble into something resembling life. Every flicker we fail to confirm is a missed chance to understand how electricity sculpts worlds. Until we send probes tough enough to survive long-term in that acidic inferno, Venus's disappearing lightning will keep vanishing into the clouds, leaving us to wonder if we're chasing ghosts or standing at the edge of a revelation. Deep in the swirling chaos of Venus's atmosphere, something unexpected flickers to life, a fleeting river of wind so fast it defies the planet's own rules. In 2015, Japan's Akatsuki orbiter caught it in action, a narrow, high-speed jet stream racing along the equator at nearly 360 kilometers per hour, a tempest in an already storm-racked sky. Then, just as suddenly as it appeared, it vanished. Unlike Earth's relatively stable jet streams, which shape weather patterns for months, this Venusian streak was here one moment and gone the next, leaving scientists scrambling to explain how such a transient fury could even exist. What makes this jet stream so baffling isn't just its speed, it's the timing. Akatsuki spotted it during a rare gap in Venus's usual cloud cover opacity, as if the planet briefly lifted its veil to reveal a secret. The stream formed at an altitude of about 60 kilometers, sandwiched between layers of sulfuric acid haze, yet it didn't behave like any atmospheric feature we've seen elsewhere. Earth's jet streams are driven by temperature contrasts and planetary rotation, but Venus spins agonizingly slow. One day there lasts longer than its entire year. Traditional models insist such sluggish rotation shouldn't spawn concentrated wind tunnels, let alone ones that appear and dissolve like smoke. One theory points to gravity waves, not the cosmic ripples of black holes, but massive pressure surges generated when Venus's atmosphere slams into mountain ranges. These waves could ripple upward, transferring energy until they ignite a temporary wind tunnel. Another idea suggests the jet might be a runaway feedback loop, where solar heat unevenly baking the cloud tops creates instability, accelerating winds until they briefly synchronize into a coherent stream. Then there's the wild card: unknown chemistry. The sulfuric acid clouds at that altitude undergo constant phase changes, vaporizing and condensing in a cycle that might release latent heat, acting like bursts of fuel for the winds. But the real puzzle is why it doesn't last. On Earth, jet streams stabilize because of our planet's rapid spin and solid surface. Venus, with its languid rotation and smooth topography, lacks those anchors. The jet might be a fragile phenomenon, collapsing as soon as the energy feeding it dissipates like a whirlpool in a bathtub, swirling vividly until the water settles. Or perhaps it's seasonal, tied to some hidden cycle we haven't decoded yet. Every explanation feels like grasping at smoke, and that's what makes this mystery so electrifying. What's at stake isn't just understanding Venus, it's about rewriting the playbook for planetary atmospheres. If a jet stream can flicker in and out of existence on a world with no oceans, no seasons, and barely any rotation, what other atmospheric quirks might lurk on exoplanets with even stranger configurations? Venus, as always, refuses to play by the rules, teasing us with glimpses of its chaotic heart before slamming the door shut. Until another spacecraft catches this ghostly jet in the act, we're left staring at the data, wondering what other secrets those acid clouds might be hiding, and how many more times they'll append everything we thought we knew. Among the swirling chaos of Venus's sulfuric acid clouds, one structure stands out not for its violence but for its eerie perfection. Every few decades, a colossal Y-shaped formation emerges in the planet's upper atmosphere, stretching thousands of kilometers across like a ghostly scar etched into the sky. This isn't some fleeting weather pattern. It lingers for months, stubbornly holding its shape against the planet's hurricane-force winds. What makes this phenomenon so unsettling is its precision. Nature rarely creates such geometric perfection without a reason, and yet on Venus, this colossal Y appears again and again, defying every expectation. The Y's origins might lie in a phenomenon called an atmospheric wave, a ripple of pressure and wind triggered by Venus's bizarre topography. Unlike Earth, where mountain ranges and oceans shape our weather in obvious ways, Venus hides its landscapes under a smothering blanket of clouds. But beneath that veil, towering volcanoes like Mont Mons and sprawling highland plateaus could be sending invisible shockwaves upward. As these waves collide with the planet's super-rotating atmosphere, they might carve out that distinctive Y shape, like a stone distorting the flow of a river. Some scientists compare it to Earth's own standing waves, stationary patterns that form downwind of major mountain ranges. Except on Venus, the effect is magnified to a planetary scale. But here's where the mystery deepens. These Y-shaped clouds don't just form, they lock in place for months, resisting the atmosphere's relentless churn. On Earth, even the most powerful storms dissipate within weeks. Venus's Y, though, behaves more like a cosmic fingerprint, reappearing in the same basic configuration across decades of observations. One theory suggests the planet's slow rotation plays a role, creating stable resonance zones where atmospheric waves reinforce rather than disrupt each other. Another idea points to the sulfuric acid clouds themselves, which might act like a viscous fluid at high altitudes, allowing structures to persist far longer than they should. The most tantalizing possibility, the Y could be a visible echo of something hidden below. Just as doctors use ultrasound to map a patient's bones, scientists might be seeing the atmospheric imprint of Venus's uncharted geology, ancient lava tubes, buried mountain ranges, or even vast tectonic scars. If so, this recurring pattern isn't just a curiosity. It's a breadcrumb trail leading us toward the planet's deepest secrets. Every time that Y reappears, it's as if Venus is whispering a clue, daring us to decode what lies beneath its acid-soaked shroud. Until we land a fleet of probes or pierce those clouds with advanced radar, the Y remains a riddle written in vapor, one that could redefine how we understand atmospheres, not just on Venus but on worlds far beyond. Venus's tesserae terrain looks like something out of a fractured dream, vast, shattered highlands stretching across the planet's surface like a colossal pane of glass dropped from the heavens. These jagged regions, some as large as continents, are crisscrossed with ridges and grooves in chaotic patterns, as if the ground itself had been crumpled, stretched, and frozen in time. No feature like this exists on Earth, and that's what makes it so perplexing. Are these the scars of ancient tectonic battles, a sign Venus once had plate tectonics like our own world? Or are they the product of something far stranger, lava flows so immense they warp the planet's crust into these eerie geometric wounds? The case for tectonics hinges on the tesserae's resemblance to Earth's most deformed landscapes. Imagine the Himalayas, but instead of orderly mountain ranges, picture a mess of intersecting fractures, as if the crust had been shoved, pulled, and twisted from multiple directions at once. Some researchers argue this chaos points to a time when Venus's crust was broken into mobile plates, grinding against each other before the planet's stifling heat shut down the system. Without the cooling effect of oceans or rapid rotation, Venus's lithosphere may have grown too thick and rigid, locking the plates in place and leaving these tesserae as tombstones for its lost tectonic activity. If true, it would mean Venus and Earth started as twins, only for one to suffer a geological seizure that left it frozen in time. But there's a competing theory, one that turns the tesserae into something even more alien. Instead of tectonic collisions, these fractured highlands might be the work of lava. Not the thin, runny flows we see on Earth, but vast, viscous outpourings so thick they didn't just cover the surface, they smothered and strained it. Picture syrup spreading over a sheet of ice, cracking and buckling under its own weight. On Venus, where volcanic eruptions may have once drowned entire regions, similar forces could have bent the crust into these labyrinthine shapes. Radar maps show some tesserae sitting like islands amid smoother plains, as if they're the last remnants of an older landscape half swallowed by lava. What's truly bizarre is how little erosion these features show. Venus's atmosphere is corrosive enough to dissolve rock over time, yet the tesserae's sharp edges persist, suggesting they might be relatively young, or that some process keeps renewing them. Could underground magma still be shifting, subtly deforming these regions even now? Or are we seeing the aftermath of a single, catastrophic event that reshaped the planet in a geological instant? Every theory runs into the same roadblock. Venus's surface is so hostile, so shrouded in mystery, that even our best orbital radar can only hint at the truth. The tesserae's deeper significance lies in what they say about planets everywhere. If they're tectonic fossils, Venus becomes a cautionary tale for how worlds lose their dynamism. If they're volcanic, they redefine what lava can do under extreme conditions. Either way, these fractured highlands are more than just a geological oddity. They're a puzzle piece in understanding why Earth stayed alive while its twin turned to stone. Until we land a rover amid those cracked plateaus or drill into their origins, the tesserae will keep their secrets, standing as silent witnesses to a time when Venus might have been as vibrant as our own world before something went terribly wrong. Venus should have a magnetic field, by all rights a planet its size, with a molten iron core not so different from Earth's, ought to generate a protective shield against the solar wind. And yet, when scientists measured Venus's magnetism, they found almost nothing. Just a whisper of induced magnetism, a faint echo created when the sun's charged particles interact with the upper atmosphere. The absence of a global magnetic field isn't just odd, it's a violation of planetary norms, and it might hold the key to understanding why Venus turned into the hellscape it is today. So why the silence? Earth's magnetic field comes from what's called a dynamo effect, a self-sustaining cycle where swirling liquid iron in the outer core generates electric currents, which in turn produce our planet's protective magnetic bubble. Venus has the ingredients: a molten core, rotation albeit slow, and convective heat, but something's broken the machine. One leading theory blames the planet's lethargic spin. A Venusian day lasts 243 Earth days longer than its entire year. Without the Coriolis forces generated by rapid rotation, the molten iron in Venus's core might not churn efficiently enough to kickstart that dynamo. It's like trying to stir a pot of syrup with a sluggish hand. The movement just isn't vigorous enough to create a sustained current. Then there's the heat problem. Earth's core loses heat through plate tectonics, with cold slabs of crust diving into the mantle and keeping the engine primed. Venus, though, seems to lack active plate tectonics. Its crust might act like a stifling blanket, trapping heat until the core cools unevenly, disrupting convection. Some models even suggest Venus's core solidified partially, leaving too little liquid metal to power a dynamo. Whatever the cause, the result is the same: a planet left defenseless against the sun's relentless barrage. The consequences are catastrophic. Without a magnetic field, Venus's atmosphere has been exposed to the solar wind for billions of years, stripped molecule by molecule. Hydrogen, oxygen, even water vapor, all torn away by charged particles in a slow-motion hemorrhage. Compare that to Earth, where our magnetic shield deflects most of this onslaught, preserving not just our air but our oceans. Venus might have once had both, but without protection, they bled into space, leaving behind a dense coffin of carbon dioxide. But here's the twist: Venus's lack of a magnetic field might not be permanent. Some researchers argue it could flicker on and off over geologic time, like a faulty light bulb, as the core's conditions change. There's even evidence from ancient rocks on Earth suggesting our own magnetic field has weakened or reversed at times. If Venus once had intermittent magnetism, it could explain why the atmosphere isn't completely gone. Pockets of protection might have spared just enough gas to maintain its crushing pressure. The implications stretch far beyond one planet. Astronomers have found thousands of exoplanets in the so-called habitable zone, but Venus screams a warning: size and location aren't enough. A world might have all the right ingredients for life, but without a magnetic shield, it could end up as barren as our twisted twin. Understanding Venus's silent core isn't just about solving a planetary puzzle, it's about recognizing how fragile a planet's life support system really is. One missing piece and the whole machine grinds to a halt. At Venus's north and south poles, twin storms rage unlike anything else in the solar system, colossal vortices wider than continents, spinning with chaotic fury yet locked in place like cosmic whirlpools. These aren't your average hurricanes, they're shape-shifting monsters, morphing from hourglass figures to wobbly figure eights to distorted teardrops without warning. While Saturn boasts its orderly polar hexagon, Venus's vortices are a study in anarchy, defying every expectation of how planetary weather should behave. What makes these storms so bizarre isn't just their size, it's their structure. Most vortexes, like Jupiter's Great Red Spot or Earth's polar jet streams, have relatively stable cores. But Venus's polar twins are hollow, with winds screaming around an eerily calm central eye. Imagine a donut-shaped tornado where the fiercest winds circle an empty void, sucking atmospheric gases downward in a slow, suffocating spiral. Even stranger, these vortices don't sit neatly over the poles. They wobble like unbalanced tops, sometimes drifting hundreds of kilometers off-center before snapping back. The driving force behind this chaos might lie in Venus's super-rotating atmosphere. As those hurricane-speed winds barrel toward the poles, they collide and plunge downward, creating a violent mixing bowl of turbulence. Unlike Earth, where the Coriolis effect organizes storms into neat spirals, Venus's sluggish rotation lets the vortices fracture into ever-changing forms. Some scientists compare it to water draining from a bathtub, except the drain keeps moving and the water's laced with sulfuric acid. But the biggest mystery is their persistence. These vortices have raged for at least half a century, possibly much longer, despite Venus's lack of oceans or seasons to feed them. One theory suggests they're sustained by planetary scale waves, ripples in the atmosphere generated by mountain ranges or temperature extremes that pump energy into the poles like a cosmic piston. Another idea points to chemical reactions in the clouds, where sunlight breaking apart sulfur compounds releases heat, fueling the storms from within. Yet nothing fully explains their dual nature. Saturn has one hexagon, Jupiter has one great red spot. Venus, it insists on two vortices, each dancing to its own chaotic rhythm. Are they interconnected, or does each pole operate independently? And why do they sometimes sync up, mirroring each other's shapes for brief moments before diverging again? Every answer leads to deeper questions, reminding us that even in death, Venus refuses to be predictable. These twin storms aren't just weather. They're a window into the untamed physics of alien atmospheres, where the rules we know are merely suggestions. Venus doesn't just hide its secrets in swirling acid clouds or scorching lava fields, it broadcasts them. Among the most puzzling signals picked up by spacecraft are bursts of radio waves, crackling through the planet's atmosphere like static from a scrambled radio station. These aren't random noise, they're structured, repetitive, and eerily similar to the natural radio emissions we've detected from Jupiter's auroras. But Venus has no global magnetic field to generate those dazzling light shows. So what's sparking these electric whispers in the dark? The first clues came from NASA, a pioneer Venus orbiter in the late 1970s. As it skimmed the upper atmosphere, its instruments caught abrupt spikes of radio energy, some lasting mere milliseconds, others stretching for minutes. At first, scientists assumed they'd found proof of lightning, fitting neatly with the Venera probe's earlier claims, but the signals didn't match Earth's thunderstorm patterns. Instead of random bursts, these radio waves pulsed with a strange regularity, almost as if something was tuning them. Even stranger, they seemed to cluster around specific altitudes, echoing strongest about 100 kilometers above the surface, where the atmosphere thins into the ionosphere. Here's where the mystery twists. Jupiter produces nearly identical radio bursts near its poles, where magnetic fields funnel charged particles into shimmering auroras. These emissions, called whistlers for their falling pitch sound when converted to audio, are the universe's own radio station, powered by electrons spiraling along magnetic field lines. But Venus lacks both auroras and a strong magnetic field, so how can it mimic Jupiter's soundtrack? One theory points to fleeting magnetic bubbles, small, temporary fields generated by solar wind interactions with Venus's ionosphere. These pockets of magnetism might not shield the planet, but they could twist electrons just enough to produce radio waves as they snap back into place. Then there's the lightning debate. If Venus does have electrical storms, even weak ones, their discharges could generate radio static as they rip through the dense atmosphere. But without visual confirmation, it's like hearing thunder with no storm clouds in sight. Some researchers propose a compromise: electrical meteors. As tiny dust particles or sulfuric acid droplets collide in the upper clouds, they might spark miniature discharges too small to see, but powerful enough to send radio waves rippling outward. Picture rubbing your feet on carpet to make static shocks, except scaled up to planetary proportions. What makes these emissions more than just a cosmic oddity is what they reveal about Venus's hidden electrical heartbeat. Earth's auroras and lightning shape our atmosphere, even influencing ozone chemistry. If Venus has its own version, no matter how alien, it could be reshaping that toxic sky in ways we've barely begun to understand. Every burst of static is a clue, a piece of a puzzle linking magnetism, weather, and maybe even the planet's slow-motion suicide. Until we send probes tough enough to dive into that radio noise maelstrom, Venus will keep broadcasting its secrets in a language we're still learning to decode. And that's the haunting beauty of this mystery. Jupiter's radio songs come from a well-understood dance of particles and magnetism. Venus hums its own tune, defying explanation, as if to remind us that even in the familiar neighborhood of our solar system, some worlds play by rules we've yet to discover. Whether it's lightning without storms, magnetism without a field, or something entirely new, these radio whispers are a siren call drawing us deeper into the enigma of a planet that refuses to be silent. Even on the side of Venus shrouded in perpetual night, the darkness isn't always absolute. Every so often, the planet's night side flickers with an eerie, ghostly glow, like a dying ember in a cosmic campfire. Scientists call it the bright nights phenomenon, and it's one of the strangest atmospheric quirks in the solar system. Unlike Earth's auroras or Jupiter's swirling storms, this isn't light reflected or generated by some obvious energy source. Instead, it's as if Venus's atmosphere itself is exhaling tiny bursts of radiance, pulsing faintly against the blackness of space. The leading explanation points to oxygen atoms, born from the violent breakup of carbon dioxide and sulfur dioxide molecules high in the atmosphere. During the day, sunlight tears these compounds apart, sending oxygen atoms spiraling into the upper layers. When night falls, these atoms drift downward, colliding and recombining into molecular oxygen, a process that releases energy in the form of a dim, otherworldly glow. It's similar to what happens in Earth's own airglow, a faint luminescence visible from orbit, but Venus's version is far more sporadic and unpredictable. On Earth, the glow is steady. On Venus, it comes and goes like a faulty neon sign, flaring in some regions while leaving others pitch black. But oxygen alone might not tell the whole story. Another theory suggests meteoric dust could be the secret ingredient. Venus's gravity constantly pulls in microscopic debris from space, remnants of comets and asteroids vaporized in the upper atmosphere. As these particles collide with atmospheric gases, they might trigger fleeting chemical reactions, sparking patches of light like cosmic fireflies. Some researchers even speculate that Venus's thick clouds could act as a lens, scattering and amplifying starlight or sunlight lingering just below the horizon. What makes this glow so baffling isn't just its faintness, it's the randomness. Unlike the steady atmospheric shimmer seen on Earth or Mars, Venus's bright nights appear in patches, sometimes lingering for hours before vanishing without a trace. Early observations by the European Space Agency's Venus Express orbiter caught these glimmers in infrared, revealing a nightside far more dynamic than anyone expected. One night, a hemisphere might pulse with diffuse light. Weeks later, the same region could plunge into total darkness, as if the planet's atmosphere forgets how to shine. The implications stretch beyond just another Venusian oddity. If oxygen recombination is the engine behind these glows, it could mean the planet's upper atmosphere is far more chemically active than we thought, a place where molecules fracture and reform in a never-ending dance. If meteors are the cause, it would suggest Venus is hoarding a hidden reservoir of cosmic dust, invisible to our telescopes. Either way, the bright nights are a reminder that even in the most hostile environments, the universe finds ways to surprise us. Venus's night side shouldn't glow at all, yet somehow, against all odds, it does. Every flicker is a whisper from a world that refuses to be understood, challenging us to look closer, dig deeper, and unravel one more piece of its endless mystery. Venus's surface tells a story written in scars, but not the kind you'd expect. Of the 900 or so confirmed impact craters dotting the planet, something stands out immediately. They're all roughly the same size. Unlike Earth or the Moon, where you'll find everything from city-sized basins to tiny pockmarks, Venus's craters are eerily uniform, with almost none smaller than 3 kilometers wide. It's as if something or some force has been selectively erasing the smaller impacts, leaving behind only the largest wounds. This bizarre pattern isn't just a quirk, it's a cosmic crime scene, and the clues point to 2 possible culprits: an atmosphere brutal enough to vaporize incoming space rocks before they hit, or a planet-wide resurfacing event so catastrophic it reset the geological clock. Let's start with the atmospheric filter theory. Venus's air is 90 times thicker than Earth's, a soupy, corrosive blanket that turns small asteroids into fireballs long before they reach the ground. Picture a meteor screaming in at hypersonic speeds, only to slam into a wall of carbon dioxide so dense it's like hitting concrete. Smaller rocks, the kind that would leave craters the size of football stadiums on Earth, simply disintegrate under the pressure, burning up in midair or exploding as airbursts. Only the biggest, most durable projectiles, those heavier than a few hundred meters across, can punch through and leave a dent. This would explain why Venus lacks the freckling of small craters we see elsewhere. But here's the catch: even this theory doesn't quite account for the sheer absence of all smaller impacts. Some should have slipped through over billions of years, raising suspicions that something else is at play. That's where the resurfacing theory comes crashing in. Around 500 million years ago, a blink in geological time, Venus may have suffered a planet-wide volcanic apocalypse. Imagine lava floods so vast they didn't just fill valleys, they drowned entire continents, burying older terrain under miles of fresh basalt. This global reboot would have wiped the slate clean, erasing countless smaller craters while leaving only the deepest, most resilient ones behind. The numbers align eerily well. Most of Venus's craters show little weathering, suggesting they're relatively young, and their distribution is oddly random, as if stamped onto a blank canvas after the resurfacing event. Yet contradictions linger. If Venus was resurfaced so recently, why are there still ancient-looking features like tesserae lurking amid the volcanic plains? And why do some craters appear partially flooded by lava while others sit pristine, as if the flows deliberately avoided them? The answer might lie in a hybrid scenario. Perhaps Venus didn't reset all at once, but in violent pulses, with some regions staying untouched for longer. Or maybe its atmosphere wasn't always this thick, meaning smaller craters could have formed early on before the air grew deadly enough to vaporize incoming debris. The implications stretch far beyond crater counting. If Venus really did repave itself in a single cataclysm, it challenges everything we know about planetary geology. Earth's surface constantly recycles through plate tectonics, and Mars's volcanoes sputter intermittently, but Venus seems to operate in cycles of dormancy and fury, like a pressure cooker waiting to explode. Understanding these craters isn't just about solving a distribution puzzle. It's about decoding whether Venus is a planet trapped in geological stasis or a dormant dragon biding its time until the next eruption. Every unnervingly uniform crater is a silent witness to forces we've yet to fully grasp, hiding secrets in plain sight on a world that refuses to follow the rules. Rising from Venus's hellish plains like giant blisters, the so-called pancake domes are one of the planet's most distinctive and baffling geological features. These bizarre formations stretch up to 65 kilometers across but stand less than a kilometer high, with steep, cliff-like sides and eerily flat tops that look like they've been planed off by a cosmic knife. Unlike the classic shield volcanoes of Hawaii or the explosive cones of Earth, these domes seem to defy conventional volcanology. Their secret lies in the lava that built them, not the runny basalt we're familiar with, but an ultra-thick, sticky slurry more akin to toothpaste squeezed slowly from a tube. What makes these domes especially puzzling is their clustering. They don't scatter randomly, they huddle together in groups, often near coronae, the sprawling ring-shaped fractures that hint at ancient volcanic upheavals. One leading theory suggests these regions sit atop hotspots where plumes of molten rock well up from Venus's mantle, oozing a silica-rich magma so viscous it piles up instead of spreading out. On Earth, similar lava forms rare domes like California's Mono Inyo craters, but Venus's extreme surface pressure, 90 times heavier than ours, would have squashed the lava's gas bubbles, making it even denser and more sluggish. But here's the twist. The dome's peculiar shapes might be more than just a curiosity. They could be a window into Venus's hidden guts. The lava's composition suggests a mantle far richer in silica than Earth's, possibly due to an ancient era of continent-like crust that melted back into the planet's interior. Or maybe Venus's volcanoes tapped into pockets of magma chemically altered by eons of baking under that crushing atmosphere. Either way, each dome is like a fossilized bubble of mantle chemistry, preserving clues about processes we've never witnessed directly. The oddest detail, many of these domes lack obvious vents. On Earth, even the stickiest lava domes usually have a central crater or fissure where molten rock pushed through. Venus's pancakes, though, often appear seamless, as if the lava somehow seeped up through invisible pores in the ground before hardening into these sprawling disks. Some researchers think the domes might be the remnants of underground lava chambers that lifted the surface like a blister, then drained away, leaving behind an empty shell that collapsed into its current flat-topped form. Yet the biggest question isn't how they formed, it's why they stopped. These domes aren't scattered across Venus evenly. They're frozen in specific regions, as if the planet's volcanic engine sputtered out mid-process. Did Venus's mantle cool just enough to thicken the remaining magma, turning it too sluggish to erupt? Or did some global catastrophe, like that suspected resurfacing event, rewire the planet's plumbing, shutting off these oozing taps forever? Every dome is a time capsule, holding answers not just about Venus's past, but about how rocky worlds evolve when heat, pressure, and chemistry collide in ways we're only beginning to imagine. Standing on one of these domes, if you could survive the heat and pressure, you'd be walking on a relic of planetary violence, a place where lava fought against gravity and lost, leaving behind these strange, flattened monuments. They're more than geological oddities. They're puzzles written in stone, waiting for us to decode what they say about the twin we thought we knew, and the secrets it still keeps buried under centuries of silence. Venus's atmosphere has a sulfur dioxide problem, one that refuses to stay consistent. Unlike Earth, where volcanic eruptions or industrial output might spike this gas temporarily, Venus's sulfur levels swing wildly with no clear explanation. In just a few years, concentrations can plummet by half, then mysteriously rebound, as if the planet itself is breathing the stuff in and out. These aren't minor tweaks, they're planetary scale fluctuations, and they've split scientists into two camps. Those convinced active volcanoes are pumping sulfur into the skies, and those who suspect we're witnessing an entirely new form of atmospheric alchemy. The volcanic camp points to Earth as Exhibit A. Here, eruptions like Mount Pinatubo in 1991 blasted millions of tons of sulfur dioxide into the stratosphere, cooling global temperatures for months. Venus, with its rampant volcanism, should logically do the same, except we've never caught it in the act. Proponents argue that hidden eruptions might be belching sulfur beneath the clouds, explaining the sudden surges. Some even trace the gas's dips to scrubbing by sulfuric acid clouds, which could absorb sulfur dioxide before raining it back to the surface. But there's a hitch: Venus's drops happen too fast. Earth's volcanic sulfur lingers for years. Venus's vanishes in months, suggesting something far more aggressive is at work. That's where the atmospheric chemists raise their eyebrows. Venus's thick air might be transforming sulfur dioxide in ways we've never seen. One theory suggests sunlight breaks apart sulfuric acid droplets high in the clouds, releasing sulfur trioxide, which then reacts further to lock away the sulfur in unexpected compounds. It's like a cosmic game of hide and seek, where the gas isn't disappearing, it's shape-shifting. Another idea involves metallic ions, fleeting particles like iron or chlorine that could catalyze reactions, bundling sulfur into solid aerosols that drift downward. These processes wouldn't just explain the drops, they'd imply Venus's atmosphere is a vast, self-regulating chemical reactor, far more dynamic than its stagnant surface suggests. The stakes here are higher than academic debate. If volcanoes are the culprits, Venus isn't the geologically dead world we once assumed. It's a simmering pressure cooker, still reshaping itself in fits and starts. But if the atmosphere alone drives these swings, it means we've underestimated how alien planetary chemistries can be. Either answer rewrites the rules. Upcoming missions like NASA Veritas might finally settle the score, mapping heat signatures from orbit to catch lava flows red-handed. Until then, those yo-yoing sulfur levels remain a tantalizing riddle, one that reminds us how much we still have to learn about the twisted sister sharing our sun. Venus's upper atmosphere shouldn't be this cold. That's the baffling truth scientists keep running into. A layer of the planet's sulfuric acid clouds, roughly 70 kilometers above the surface, where temperatures plunge to a frigid -70 degrees Celsius. For a world notorious for its oven-like surface, this icy pocket is more than just odd. It's a direct challenge to everything we thought we knew about greenhouse effects and planetary energy balance. If Venus's carbon dioxide blanket traps heat so ruthlessly below, why does part of its sky act like a cosmic freezer? The answer might lie in an unexpected culprit, sunlight itself. Venus's clouds reflect about 75% of the sun's rays back into space, a property known as albedo. This mirror-like quality, thanks to those thick sulfuric acid hazes, means much of the incoming solar energy never penetrates deep enough to warm the lower atmosphere. Instead, it bounces off, leaving the upper layers starved for heat. But that's only half the story. The real twist is how these clouds radiate energy away. At those high altitudes, the sulfuric acid particles act like a giant radiator, efficiently shedding heat into the void of space. It's as if Venus's atmosphere has built-in air conditioning, with the coldest zone sitting right between the scorching surface below and the slightly warmer upper haze above. Here's where the models break down. Traditional greenhouse theories predict temperatures should taper off smoothly as you rise through the atmosphere. Venus, though, creates a thermal roller coaster. One hypothesis suggests gravity waves massive ripples in the atmosphere triggered by surface mountains or wind shear, could be physically pushing cold air upward like a piston, creating this anomalous chill zone. Another idea points to the cloud's composition. Sulfuric acid isn't just a reflective blanket, it's a dynamic chemical factory. As sunlight breaks apart the molecules, the resulting reactions might sap heat from their surroundings, like ice melting in reverse. The implications stretch far beyond academic curiosity. If Venus's cold traps influence how gases circulate, they could explain why water vapor and other molecules vanish at certain altitudes, effectively freezing out of the atmosphere. Earth has its own cold traps regions like the mesosphere where noctilucent clouds form, but nothing this extreme. Understanding Venus's version might reveal hidden rules about how atmospheres redistribute heat, or even how planets lose vital molecules to space over time. What makes this mystery so thorny is the paradox at its heart. The same clouds that bake the surface under a greenhouse grip also create these frigid high-altitude pockets. It's a delicate, self-regulating system, one that could teach us about the fine line between a habitable climate and a runaway disaster. Earth's atmosphere dances to a similar tune, balancing reflection and absorption, but Venus cranks the mechanism to such extremes that it defies intuition. Every probe that dips into those cold layers doesn't just gather data. It tests whether our grasp of planetary physics is solid, or if Venus, as always, has another curveball waiting in the shadows. Perhaps the most humbling lesson here is how much we still don't understand about energy flow, even on worlds next door. Venus's cold clouds aren't just a quirk, they're a challenge, daring us to rethink how heat moves, how atmospheres breathe, and how something as simple as reflected light can twist a planet's destiny. Until we send missions capable of lingering in those icy layers, the mystery will hover, as unresolved and tantalizing as the faint glimmers of frost in an otherwise fiery sky. Venus and Earth might be planetary siblings, but their geological hearts beat to entirely different rhythms. While Earth's surface is a jigsaw puzzle of shifting tectonic plates, Venus wears its crust like a rigid, unbroken shell, a stagnant lid locked in place for reasons that still stump scientists. This isn't just a minor difference, it's a fundamental divergence in how rocky worlds evolve, and it might hold the key to why one planet thrived while the other became a hellscape. The mystery starts with their similarities. Venus is nearly Earth's twin in size and composition, with a molten metal core that should, in theory, drive the same churning mantle convection that breaks Earth's crust into mobile plates. Yet Venus's surface shows no evidence of subduction zones, mid-ocean ridges, or continental drift. Instead, its crust appears to have thickened into an immobile carapace, trapping heat beneath like a pressure cooker. One leading theory blames water, or rather, the lack of it. On Earth, water acts as a geological lubricant, soaking into rocks at subduction zones and making them pliable enough to dive back into the mantle. Venus, bone dry and scorching, might have crust so strong and brittle it can't buckle or recycle, leaving the planet stuck in geological gridlock, but the plot thickens. Some regions of Venus, like the fractured tesserae highlands, look suspiciously like fossils of ancient tectonic activity. These zones resemble Earth's most deformed terrains, where crust has been squeezed and folded like taffy. Could Venus have once had mobile plates that suddenly froze? There's a radical idea gaining traction: episodic tectonics. In this scenario, Venus doesn't recycle its crust in steady cycles like Earth, but in catastrophic spasms. Heat builds under the stagnant lid until the pressure becomes unbearable, triggering planet-wide volcanic outbursts that resurface entire regions in lava. After the purge, the crust stiffens again and the cycle starts anew. Its geology as tantrum, long periods of silence punctuated by violent reinvention. The implications are staggering. If Venus operates in these fits and starts, it challenges the assumption that plate tectonics is the default for rocky worlds. Earth's steady recycling might be the outlier, with Venus representing another viable if extreme path. This could reshape how we interpret exoplanets. A world labeled Earth-like due to size and distance from its star might actually be a stagnant lid time bomb, brewing its own apocalypse under an unyielding shell. The most haunting question isn't just why Venus lacks tectonics, it's what this means for its lifespan. Earth's plates act like a thermostat, releasing heat through volcanoes and ridges to prevent catastrophic overheating. Venus, with its clogged engine, might be slowly stewing in its own energy, explaining the extreme volcanism that periodically tears its surface apart. The same forces that shut down its tectonic regime could have also turbocharged the greenhouse effect, turning a once temperate world into a pressure cooker. Every probe we send to map Venus's gravity field or measure its quakes isn't just studying another planet. It's reading a cautionary tale about how geology can make or break a world. The absence of plate tectonics isn't a footnote in Venus's story. It might be the very reason that story turned so tragic. Perhaps the most unsettling thought is that Venus's stagnant lid isn't just a relic of the past. Some models suggest the planet could still be cycling between rigidity and chaos, with another resurfacing event lurking in its future. If so, those unbroken plains and fractured highlands aren't just geological oddities, they're chapters in an unfinished epic, waiting for the next eruption to turn the page. Understanding why Venus's crust refuses to move isn't just academic. It's a window into the fragility of planetary equilibrium, and a reminder that even twins can grow up to live wildly different lives. Amid the sulfuric glare of Venus's thick atmosphere, observers have occasionally glimpsed something unexpected, a faint, ethereal blue halo clinging to the planet's edges like a celestial afterthought. This elusive phenomenon isn't the product of Photoshop or optical illusions. It's a real, if poorly understood, feature that's been spotted by ground-based telescopes and spacecraft alike. Yet every time scientists try to pin it down, the halo vanishes like a mirage, leaving behind more questions than answers. What could possibly paint a world known for its hellish yellows and oranges with such an otherworldly tint? One leading theory points to the scattering of sunlight, but not in the way you might expect. On Earth, our sky appears blue because air molecules scatter shorter, bluer wavelengths of light more efficiently than red ones. Venus, though, lacks a clear sky in the traditional sense. Its opaque clouds should swallow sunlight whole. However, at high altitudes above the main sulfuric acid haze, there's a thin layer of tiny particles, possibly ice crystals or even metallic compounds, that could act as prisms, bending blue light just enough to create this fleeting glow. Imagine sunlight filtering through a cosmic stained glass window, with only the faintest blue fragments making it through the cracks. Then there's the wild card, unknown chemistry. Venus's upper atmosphere is a brewing ground for bizarre reactions, where sulfur dioxide mingles with trace metals and solar radiation to forge compounds we've barely begun to catalog. Some researchers speculate that exotic molecules, perhaps chlorine-based or even sulfur allotropes, could be absorbing certain wavelengths of light and re-emitting that eerie blue hue. It's akin to the way neon gas glows in a sign, except on a planetary scale. The challenge: these layers are so thin and transient that probes like Venus Express could fly right through them without detecting a definitive signal. The halo's fleeting nature adds another layer of intrigue. Unlike Jupiter's persistent auroras or Mars's dusty pink halo, Venus's blue glow appears sporadically, sometimes lasting hours, other times flickering out in minutes. This unpredictability suggests it's tied to dynamic processes, maybe solar storms bombarding the upper atmosphere, or sudden surges of volcanic gases reacting with sunlight. Earth's own upper atmosphere occasionally dazzles with night-shining clouds, but Venus's version seems to operate on its own cryptic schedule. What makes this mystery so compelling isn't just the what, but the why. If the halo stems from scattered light, it could reveal hidden layers of Venus's atmospheric structure, much like X-rays expose bones beneath skin. If it's chemical, it might hint at unseen reactions that could influence the planet's long-term climate. And if it's something entirely new, well, that's the thrill of Venus, a planet that refuses to be pigeonholed. Every wisp of blue is a breadcrumb, tempting us to look closer, to send smarter probes, and to decode the subtle language of a world that still has so much left to say. For now, the blue halo remains a ghost in the data, a whisper of beauty in an otherwise brutal landscape. It's a reminder that even in the most inhospitable corners of the cosmos, nature finds ways to surprise us, painting the void with strokes we're only beginning to perceive. And until we catch this phantom in the act, it will hover at the edge of our understanding, a celestial will-o'-the-wisp beckoning us deeper into Venus's labyrinth of secrets. In 2007, something strange stirred in Venus's perpetual shroud of clouds, a vast, inky blot darker than the surrounding sulfuric haze, sprawling over thousands of square kilometers. The European Space Agency's Venus Express orbiter caught it first, a smudge so pronounced it stood out like a bruise against the planet's pale, reflective atmosphere. This wasn't just a fleeting shadow. The spot persisted for days, morphing in shape and intensity, as if something beneath those clouds was stirring the pot. The discovery ignited a firestorm of debate. Was this the long-sought proof of active volcanism, or evidence of an atmospheric tantrum unlike anything we'd seen before? The volcanic camp had compelling reasons to suspect an eruption. Venus's surface is littered with evidence of past lava flows, and the planet's sulfur dioxide spikes hinted at possible underground activity. If a massive plume of ash and gas had punched through the clouds, it could explain the spot's darkness. Volcanic particulates swirling in the upper atmosphere, absorbing sunlight like a cosmic ink stain. Comparisons were drawn to Earth's own volcanic titans, like the 1991 eruption of Mount Pinatubo, which spewed aerosols so high they dimmed global sunlight for years. But Venus's spot lacked the telltale thermal signature of fresh lava, leaving scientists to wonder if they were seeing the ghost of an eruption rather than the act itself. Then there's the atmospheric disturbance theory. Venus's skies are a roiling mess of super-rotation and chemical chaos, where even subtle shifts can trigger cascading effects. Some researchers argued the spot might be a colossal gravity wave, not the space-time ripples of Einstein's relativity, but a planetary scale shudder in the atmosphere. Picture wind slamming into a mountain range like Maxwell Montes, then ricocheting upward like a tidal wave, dragging dense, dark material from the lower atmosphere into the sunlight. These waves could distort cloud layers, creating temporary patches of contrast. Venus Express had already spotted smaller, similar features, but nothing this vast or persistent. The plot thickened when scientists noticed the spot's eerie behavior. Unlike typical weather patterns which drift predictably with the winds, this anomaly lingered in place as if anchored by some unseen force. Its edges rippled and frayed, yet the core remained stubbornly intact, defying the planet's hurricane-speed winds. Had it been a volcanic plume, it should have dispersed or drifted. Instead, it pulsed as though breathing in sync with some hidden rhythm. Even now, the black spot remains an enigma, a Rorschach test for planetary scientists. For volcano hunters, it's a smoking gun, proof that Venus still flexes its geological muscles in explosive bursts. For atmospheric physicists, it's a masterpiece of fluid dynamics, a testament to how energy ripples through alien skies. The truth might lie somewhere in between, a reminder that Venus doesn't play by Earth's rules. What makes this mystery endure isn't just the lack of answers, it's the tantalizing possibility that both sides might be right. Perhaps the spot was a volcanic eruption that triggered atmospheric shock waves, or an atmospheric wave that uncloaked volcanic gases from below. Either way, it's a window into the forces that still shape Venus, hidden beneath those impenetrable clouds. Until we send probes capable of peeling back those layers, the black spot will hover in our data, a shadowy question mark on the face of our closest planetary neighbor. And like so much about Venus, it refuses to be ignored. Venus's atmosphere doesn't just move, it convulses. In 2015, Japan's Akatsuki orbiter spotted something that shouldn't exist: gravity waves spanning nearly 10,000 kilometers, rippling through the planet's sulfuric acid clouds like the wake of a cosmic speedboat. These weren't the gentle undulations of Earth's jet streams. They were planetary-scale tremors, vast enough to stretch from New York to Sydney and back again. The real shock: Venus has no mountain ranges tall enough to generate such monstrosities. On Earth, gravity waves form when wind slams into obstacles like the Rockies or the Andes, sending ripples upward through the atmosphere. But Venus's highest peak, Maxwell Montes, stands just 11 kilometers tall, nowhere near enough to kickstart waves of this magnitude. So what invisible hand is shaking Venus's skies with such violent precision? One theory points to the planet's suffocating heat. Venus's surface bakes at 470 degrees Celsius, turning its lower atmosphere into a bubbling cauldron of convection. As superheated gas rises and collides with cooler layers above, it might generate explosive updrafts not unlike the boiling water in a geyser. These vertical explosions could launch shockwaves rippling outward, creating gravity waves that propagate horizontally for thousands of kilometers. Picture throwing a rock into a pond, except the pond is an ocean of sulfuric acid, and the rock is a thermal detonation powerful enough to distort an entire planetary atmosphere. Then there's the wild card: atmospheric resonance. Venus's slow rotation and thick air might act like a giant echo chamber, amplifying smaller waves until they merge into continent-sized behemoths. On Earth, similar phenomena occur in our oceans, where tides and currents occasionally sync up to produce rogue waves. Venus's version could be far more extreme, with atmospheric tides driven by solar heating pumping energy into these waves until they swell to unimaginable scales. Some models even suggest the planet's global circulation patterns create waveguides, channeling energy along specific latitudes like an invisible highway for atmospheric turbulence. But the most haunting possibility is that we're seeing the fingerprints of Venus's hidden geology. While its mountains might be too short to trigger these waves directly, vast lava plains or subterranean magma chambers could be leaking heat unevenly, creating thermal gradients potent enough to stir the atmosphere from below. It's as if the planet itself is breathing exhaling bursts of heat that ripple through its shroud of clouds. Data from Akatsuki hints at this, with the waves often clustering over specific regions, like the volcanic highlands of Atla Regio, as if tethered to something beneath the surface. What makes these gravity waves more than just a meteorological oddity is what they reveal about energy flow on a planet without boundaries. Earth's weather is shaped by oceans and mountains. Venus, with its flat plains and homogeneous surface, shouldn't have such dramatic atmospheric scars. Yet here they are, giant, shimmering wrinkles in the fabric of its sky, defying every model we've built. They're a reminder that even the smoothest, most featureless worlds can harbor turbulence beyond our imagination, and that sometimes the most profound mysteries don't come from what we can see, but from the invisible forces twisting the canvas itself. Every time these waves emerge, they're not just distorting Venus's clouds, they're distorting our understanding of how atmospheres work. If a planet with no obvious triggers can spawn such colossal disturbances, what other atmospheric surprises might lurk on exoplanets with even stranger configurations? Venus, as always, refuses to be predictable, leaving us to wonder whether we're witnessing a freak accident of physics or a fundamental process we've yet to decode. Until we land probes capable of feeling these atmospheric tremors firsthand, the giant gravity waves will keep rolling through Venus's skies, silent and relentless, like the echoes of a storm we can't quite hear. Rising from Venus's northern hemisphere like a frozen tidal wave of rock, Terra is a land of staggering contradictions. This sprawling highland, roughly the size of Australia, boasts some of the most Earth-like mountain ranges in the solar system, including Maxwell Montes, which towers 11 kilometers above the surrounding plains, rivaling Everest in scale. Yet the moment you ask how these mountains formed, the familiar vanishes. Earth's peaks are born from tectonic collisions, where continental plates crunch together like slow-motion car wrecks. But Venus has no plate tectonics, no continental drift, no shifting crust to sculpt such grandeur. So why does Terra look like it was ripped from our own planet's playbook and pasted onto a world that should reject everything it represents? The mystery begins with the terrain itself. Ishtar's western edge, a region called Lakshmi Planum, is a vast plateau ringed by jagged, folded mountain belts reminiscent of the Himalayas. Radar maps reveal intricate patterns of ridges and valleys, as if some gargantuan force crumpled the landscape like tinfoil. On Earth, this would scream tectonic collision. But Venus's crust is a single, unbroken shell, a stagnant lid with no mobile plates to generate such violence. One theory suggests Ishtar might be the scar of a downdraft, where a chunk of heavy lithosphere sank into the mantle eons ago, dragging the surrounding crust inward until it buckled upward in protest. Imagine stepping on a rug, the edges bunch up into ridges under your weight. Venus's version would have played out over millions of years, with Maxwell Montes as the ultimate wrinkle in a planetary scale tapestry. Then there's the volcanic angle. Ishtar's eastern highlands are pocked with volcanic features, from sprawling lava flows to peculiar, arachnoid, fractures, spidery networks of ridges possibly formed by magma pushing against the surface. Some researchers argue that Ishtar's mountains could be the product of monstrous volcanic uplift, where plumes of molten rock bulge the crust outward like a blister before solidifying into these colossal highlands. The wrinkle-like ridges, perhaps the crust cracking under the strain, like dried mud atop a shrinking puddle, But this theory runs into problems too. Volcanic mountains like Hawaii's Mauna Loa tend to have gentler slopes and distinct vent structures. Ishtar's peaks are steep, knife-edged, and suspiciously devoid of obvious volcanic roots. The most unsettling possibility is that Ishtar Terra is a fossil, a relic from a time when Venus did have fleeting plate tectonics. Radar scans reveal hints of subduction-like zones along its margins, where crustal material might have once plunged into the mantle. If true, Ishtar could be a snapshot of a planetary metamorphosis, the moment Venus's geology locked into its current stagnant lid state. Picture a machine seizing mid-cycle, leaving gears forever frozen in awkward positions. This would make Ishtar Terra more than just a geological oddity. It would be a time capsule preserving the death throes of an entire planetary system. What makes this paradox so critical isn't just academic, it forces us to reconsider how planets evolve. Earth's tectonics are often seen as the gold standard for habitable worlds, cycling nutrients and stabilizing climates over eons. But Ishtar Terra whispers a heresy. Maybe there are other paths to mountain building, other ways for planets to vent their heat and fashion landscapes. The same forces that forged Ishtar might have also accelerated Venus's greenhouse collapse, turning it from a potential oasis into a pressure cooker. Every ridge, every valley in this alien highland is a coded message about how geology can make or break a world. As future probes map Ishtar's gravity field and subsurface structure, we're not just studying another planet's mountains, we're reading the diary of a lost twin, one that might have once been far more like Earth than we ever dared imagine. Until then, Ishtar Terra stands as a monument to cosmic irony, a place where familiar peaks tell utterly alien stories, where every resemblance to home only deepens the mystery. It's a reminder that even in the most hostile corners of the universe, nature finds ways to echo itself, not out of kinship but through the infinite creativity of physics. The next time you gaze at Earth's mountains, spare a thought for their doppelganger on Venus, silently guarding secrets that could rewrite the history of our solar system and every other. Scattered across Venus's scorching plains lie ghostly imprints of a lost world, vast, ripple-like formations frozen in time, their curves and crests so perfectly preserved they look like windswept dunes turned to stone. These aren't the shifting sand seas of Earth's deserts. They're relics, fossilized echoes of an era when Venus's winds might have danced to a different rhythm. The strangest part, these delicate structures shouldn't exist, not here, not on a planet where hurricane-force winds scream non-stop, where the atmosphere is thick enough to scour rock over geologic timescales. Yet somehow these dunes endure untouched, as if Venus itself forgot to erase them. What secrets do these ancient whispers hold, and how have they defied a climate hellbent on obliterating every trace of the past? The key lies in their composition. Earth's dunes are built from loose sand, constantly reshaped by breezes. Venus's fossilized versions, though, seem to be made of something far more resilient, possibly volcanic ash or mineral grains welded together by extreme heat and chemical reactions. Picture a sandcastle not just hardened by the sun, but transformed into glass by a blowtorch. Some researchers suspect these dunes were once mobile, sculpted by gentler winds during a fleeting period when Venus's atmosphere might have been thinner, its storms less vicious. Then, cataclysmic volcanic eruptions or a runaway greenhouse effect triggered a planetary-scale lockdown. As temperatures skyrocketed and pressures mounted, acidic vapors or searing heat could have cemented the dunes in place, turning them into permanent monuments to a lost climate. But here's the puzzle: even solidified dunes shouldn't last this long. Venus's present-day winds, packing the force of a constant Category 5 hurricane, ought to have sandblasted these features into oblivion over millions of years. Their survival suggests something extraordinary. Either the planet's wind patterns shifted dramatically after the dunes fossilized, leaving them sheltered in a rare calm zone, or the cementing process created a material so tough it laughs in the face of erosion. Radar images from NASA Magellan mission reveal some dunes clustered near volcanic highlands, where uphill winds might weaken just enough to spare them. Others sit in odd geometric patterns, their alignment hinting at ancient wind directions that no longer match today's atmospheric chaos, the most tantalizing clue. These dunes aren't alone. They're often found near other geologic time capsules' tesserae terrain, lava flows with suspiciously crisp edges, as if Venus's surface preserves scattered snapshots of different epochs. Together, they sketch a timeline of catastrophe, a world where climates didn't gradually shift but shattered in abrupt, planet-wide revolutions. If we could date these dunes, they might reveal when Venus's atmosphere went from merely hostile to apocalyptic, trapping the planet in its current inferno. Yet the biggest question isn't just about the past, it's about universality. If wind patterns can fossilize on Venus, could the same happen on exoplanets with similarly brutal climates? Astronomers have discovered super-Earths shrouded in thick, Venus-like atmospheres. Might their surfaces also hide preserved weather records waiting to be decoded? These dunes are more than geological oddities, they're testaments to the endurance of memory, even in the most unforgiving environments. Every ripple is a cipher, a message from a time when Venus might have been a place of windswept beauty rather than a scorched wasteland. Until we land a rover amid these petrified waves, they'll remain silent sentinels, guarding answers to questions we're only beginning to ask. Venus saved its most explosive mystery for last, the fleeting whisper of a gas that shouldn't exist. In 2020, astronomers dropped a bombshell. They detected phosphine in Venus's clouds, a molecule long considered a potential fingerprint of life. On Earth, phosphine is either manufactured in labs or belched out by microbes thriving in oxygen-free environments like swamps and animal guts. Finding it on Venus was like stumbling upon a smoke detector in the middle of a desert, unexpected, unnerving, and begging for an explanation. The discovery ignited a firestorm of debate, splitting scientists into two camps: those convinced we'd glimpsed the first hint of extraterrestrial biology, and others scrambling to prove it was just another quirk of Venus's toxic chemistry. The initial observations came from two telescopes, the James Clerk Maxwell Telescope in Hawaii and the Atacama Large Millimeter Array in Chile. Both peered through Venus's thick atmosphere, picking up a spectral line at exactly the wavelength where phosphine absorbs light. The signal was faint but unmistakable, hovering around 50 parts per billion in the planet's temperate cloud deck, 50 kilometers above the surface. At that altitude, temperatures hover near 30 degrees Celsius, with pressure similar to Earth's at sea level, conditions some extremophiles could theoretically tolerate. The researchers behind the study were careful, emphasizing they hadn't found life, only a molecule that life could produce, but the implications were electrifying. If not biology, what natural process could craft phosphine in such quantities on a planet devoid of industry or the geologic processes that generate it on Earth? Skeptics quickly mobilized, proposing alternative explanations. Maybe the phosphine wasn't phosphine at all. Perhaps the telescopes had misread sulfur dioxide, a gas Venus has in spades. Or maybe volcanic eruptions, though unobserved, were spewing phosphides from deep within the planet, which then reacted with sulfuric acid to form phosphine. Some even suggested micrometeorites constantly raining down on Venus's atmosphere could carry phosphorus compounds that transform under ultraviolet light. Each theory had holes. Sulfur dioxide couldn't fully account for the signal. Venus's known volcanism doesn't match the required phosphine output, and micrometeorites would need an implausibly efficient delivery system. The back and forth grew so intense that within months, other teams claimed to debunk the detection entirely, only for the original researchers to counter with reanalyzers standing by their findings. What makes this debate more than just academic bickering is what it reveals about Venus as a whole. The phosphine controversy epitomizes the planet's knack for dangling answers just out of reach. Every time we think we've pinned down a rule, whether about atmospheric chemistry, geologic activity, or the boundaries of habitability, Venus throws a curveball. The same clouds that scorch the surface below might, in their upper layers, harbor pockets where unfamiliar chemistry or even biology could persist. It's a reminder that life, if it exists there, wouldn't play by Earth's playbook. Any Venusian microbes would need to thrive in acid, shrug off desiccation, and possibly metabolize sulfur or carbon monoxide. To us, it sounds like science fiction. To Venus, it might just be another Tuesday. The phosphine saga also underscores how little we still know about our closest planetary neighbor. Despite dozens of missions, Venus's clouds remain stubbornly opaque to our instruments, its surface a blur of heat and pressure. Upcoming probes like NASA Da Vinci and Veritas aim to change that, but for now, the phosphine mystery lingers, a tantalizing maybe hovering in the data. Whether the final answer points to volcanoes, chemistry, or something far more extraordinary, one thing's certain: Venus isn't done surprising us. The phosphine debate isn't just about one gas. It's a proxy for the larger question of how bizarre a planet can become while still brushing against the edges of what we consider possible. And in that sense, it's the perfect capstone to Venus's long list of enigmas, a puzzle that refuses to be solved, daring us to look closer even as it slips back into the clouds. Venus has spent decades shattering every assumption we've ever had about planets, and these 25 mysteries are just the beginning. From its runaway greenhouse effect that turned a potential paradise into a pressure cooker, to its super-rotating atmosphere whipping around faster than the planet itself spins, to those bizarre metallic snowcaps frosting its mountaintops, every discovery feels like a cosmic prank, defying the rules we thought governed rocky worlds. The planet's missing water, its cryptic UV-absorbing clouds, the enigmatic black spots that appear and vanish like planetary Morse code, each one is a fresh puzzle begging to be solved. And let's not forget the grand finale, that controversial phosphine detection, a gas that just might hint at life floating in the sulfuric acid skies. Venus doesn't just challenge our textbooks, it rewrites them in real time, proving that even our own cosmic backyard holds secrets we've barely begun to crack. But here's the thrilling part: we're on the verge of groundbreaking answers. Missions like NASA Da Vinci Plus, set to plunge through Venus's atmosphere with sensors blazing, will finally measure its chemistry in real time, hunting for clues about water loss, volcanic activity, and yes, even potential biosignatures. Meanwhile, ESA's Envision orbiter will map the planet's surface and gravity field with unprecedented precision, peeling back those thick clouds to reveal whether volcanoes still rumble beneath. These missions aren't just about solving old mysteries, they're about uncovering new ones, proving that Venus still has stories left to tell. With every probe, we're not just exploring another world, we're testing the limits of what we thought was possible, learning that planets don't follow templates, they invent their own rules. So what's your favorite Venusian enigma? Do you think those dark streaks in the clouds are chemistry we've never seen, or something even more extraordinary? Could the planet's missing magnetic field hold the key to its apocalyptic transformation? Drop your theories in the comments, because science isn't a solo mission, it's a collective adventure. Every time we stare up at Venus glowing defiantly in our twilight sky, we're reminded how much is left to discover. The next chapter of this story isn't just written by scientists, it's shaped by curious minds everywhere daring to ask, what if? And if history's any guide, the answers will be stranger than anything we've imagined.